Hey there. In this video, I'm going to talk about something that I've seen marketers confuse a lot, a concept. So they confuse between attribution window and Adstock. These two concepts get conflated. So Adstock actually comes from the concept of statistical modeling or marketing mix modeling. It's one of the important media variable transformations. So there are at least two basic transformations that media variables go through in a marketing mix model, and they are Adstock and saturation. So Adstock basically gives you how much is going to be the delayed or decaying effect of media spend, and saturation gives you at what point the curve really flattens or saturates. Beyond that, it just doesn't make any sense to keep spending in that channel because you're not going to get any, you know, additional marginal returns. The marginal returns basically saturates. So these are the two transformations, but Adstock in particular is confusing in the sense that people often confuse it with attribution window. Window is the more familiar concept. This is what is available within, suppose, Facebook ad, meta ads, or Google ads, and Google Analytics 4 GA4. These are the tools where you can look at attribution window. But the attribution window is essentially defined by these platforms, or you can choose the attribution window. So suppose Meta offers different attribution windows. Even in Google ads, you can choose attribution windows, say 7 days, 30 days, 90 days. There are different windows. So essentially it means that within that window, if the conversion is sort of, if the conversion happens, and if the attribution is supposed to be given to that particular platform, then it is going to be given. If the conversion happens beyond that window and still attribution would have, it made sense to give attribution, the platform is not going to give attribution to itself for that particular conversion. So that's basically attribution window. So it's a predefined concept. Adstock, on the other hand, it's a derived concept. It's not predefined. It of course is predefined when you're modeling, but you can of course fine tune it, and you can understand it properly. Whether or not the effect is, how much the effect actually remains for a particular channel, and even for specific campaign initiatives for that matter. But generally, it's taken at a larger channel level. So for different channels, there will be different levels of decaying effects. So if you look at this particular chart here in front of you, this is a very nice way to compare between Adstock and attribution window. So you can see there's something called half-life in the x-axis. So half-life is nothing but that time at which the effect is halved of a particular media channel, the effect on sales, the effect on net outcome that you are measuring. So the point at which it becomes halved is your half-life. That's measured in days, and that's in the x-axis. In the y-axis, you have the share of the total Adstock effect. So how much of it, pretty much. So as you can see, in the middle right here is 50%, right? And that makes sense because the share, like I said, it ultimately is reducing, right? Over time, the effect of, so suppose someone gets exposed to an ad, right? Or you're running ads on, say, television, you're running ads to search ads. So the effect is going to decay over time, and at some point it's going to become 50% of the total initial effect that it possibly, the potential effect that it could have had. And this effect here, this is also a differentiation here. Adstock is not just defined in terms of conversions. Adstock is defined, the effect of Adstock, that is the influence. So influence is actually a better word, or maybe even effect. So it's not conversion. So it doesn't necessarily mean that 50% of all conversions that could have been achieved by this particular media spend is achieved in its half-life, which in this case is 7 days. That's not the case. Like, it may not necessarily be conversions. It could actually be like word of mouth. It could be just retaining that information. There's something called mental availability, a concept that is become very popular. I think it has been popularized by Byron Sharp, if I'm not wrong. But you can, yeah. So mental availability means that how much mentally that brand name remains available. So it's kind of like brand recall. So um, but the point is that it's not necessarily only conversions. Attribution window, on the other hand, is all about just conversion. So it's a very bottom of the funnel, very conversion oriented thought process. So the thought process is also very different. Philosophically, they're very coming from very different traditions. So one is probabilistic, one is deterministic, right? and you can see that the half-life of course varies, and once it varies for for different half-lives. So if you have a half-life of 3 days, and then you can see that the share of total ad stock effect is 20% here and 80%. So what is really showing here is within the first 7 days. So if your half life is 7 days, for instance, by that time half of your effect has been has already been sort of, the media has already has had half of its total possible effect. So if you have an attribution window of 7 days, then 50% of your actual effect, which would have been possible because and given by Adstock, is actually captured by the attribution window. So there's still 50% which is not going to be able to capture, right? If it is 3 days, actually more of it has been captured, right? Because the effect is shorter. The half life is 3 days, means that by the way, it's not just going to be double, right? It's coming from a geometric concept. The Adstock here we are considering is a geometric Adstock, depends on the model, right? So geometric means that it's going to have a sort of an exponential kind of a decrease. So it doesn't necessarily mean that it's just going to be in 6 days time that it's going to uh, it's actually going to decay over time. Okay. And so if I just look at this curve now, like share of ad stock captured by a 7-day attribution window across different half-lives, this is something that I'd shared over LinkedIn as well. So you can see that for different half-lives, this is exactly the same thing. Instead of just having it in a group bar chart, I've just shown it separately so that it's easier to see that as your half-life increases, meaning that as your effect, the longitude, the sort of longevity of your effect increases, uh, it's actually going to have lesser and lesser percentage of the total effect captured by the attribution window. And usually attribution windows are like that, like 7 days. If you create a larger attribution window, then possibly yes. And again, for different channels, so if it's a very top of the funnel channel, then your effect is going to be larger, your half life is going to be larger, and your typical attribution models or windows rather, like 7 days, they're not going to be able to capture a significant percentage. They're going to, or they are going to lose out a significant percentage of the total effect. Okay, so it's not the same thing, attribution window and half life. On the other hand, there's some math here, so we actually can look at how the math is coming about. So like I said, the ad stock or a carryover process, that's basically coming from certain modeling, and this model that we have taken here is a geometric model. And how does it vary? It uses this concept of decay factor. So alpha to the power t, so at any given time t, the decay, the impulse of one response unit, or the impulse response to one unit of spend is basically alpha to the power t. If there were additional, I mean, if it was something different than just unit spend, you would have multiplied it by the ad spend. So that would have been your ad stock decay essentially. So the decay factor to the power t is basically, and t of course is different time periods, that's your impulse to to unit spend. Okay, just to make it easier, for a full time series, like I said, this is how it would look like. So you would basically multiply it. So suppose you would have the time series xt plus, you will not actually just multiply simply by the ad spend, but you will multiply the ad spend here, as you can see, with the decaying factor with a t minus 1, which is basically the ad stock at the previous time period. So there, this is why it's called a recursive effect. There's a recursion here. So you have the ad stock given by this coic formula, coic formation. You will have a recursive effect, like ad stock at time period t is the ad spend at t plus the decay factor multiplied by the ad stock at time t minus 1. So next comes the half-life or decay factor, just to sort of understand how half-life and this alpha are related. So it's nothing but alpha to the power h is half, which gives us that alpha is nothing but 2 to the power minus 1 by h, meaning that it's 0.51 by h to the power 1 by h. That's basically the relationship. Now total long run effect. So this is basically a geometric series property. If you sum it till infinite, alpha to the power t, it actually becomes 1 by 1 minus alpha. Okay, So that's your total effect over a longer period of time. Again, this is for unit spent, remember, unit in 1 unit impulse. And then if you want it within a finite range, suppose within a window, which is what we were comparing, right, the attribution window of say w equal to 7, then what it becomes is 1 minus alpha to the power w by 1 minus alpha. Essentially, in the numerator you also have this particular factor here. This is basically a property of summation of geometric series. And then what's the share inside versus after the window, which is what we were trying to see from this table, right, this chart. So basically I'm breaking down the mathematics of that chart. And so the inside share is nothing but the share captured within the window divided by the total, right? And the total, as we have found here, is 1 by 1 minus alpha. And then you have or rather it is 1 minus alpha to the power w by 1 minus alpha. And then you have the total, which is it goes to the numerator, right, which is what is 1 minus alpha. So your share inside becomes 1 by 1 minus alpha to the power w. Alpha after share is nothing but 1 minus, right, because the total share is 100%, so it becomes alpha to the power w. It's actually going to be a slower decay for larger age. So the half-life, if you have a larger half-life, it means that your decay is smaller, essentially. If you want this document, you can actually take a look at that. I'll leave this in the description of the video. But this was essentially the mathematics and the concept. So don't confuse between Adstock and attribution window. These are related, but they're different concepts and they come from different traditions. Adstock is more from a modeling aspect of it, and attribution window is a predefined concept given by usually the different platforms. Hope this was useful. If you have any questions, do leave in the comments. Always happy to read them. But yeah, so long, and that's it for this video. I'll see you in the next one.